Students, this is problem C on lesson 6.7, problem C. We are given that OPQR is a quadrilateral with O is at 0, 0, and P is at a distance BC. So that means we are over B units and up C units, but we don't know what those units are, so we're going to call that just point P. And Q, OP, Q is at the point A plus B, C. C again is that vertical distance. B is that amount shifted to the right, and then you have this distance called A, so it's A plus B there. That's point Q. And then you have R sitting at the distance, whatever A was, and A's up here. This is the length A. We don't know what the units are, but it's A. They have to be the same. And so that means R, right here, is at A0. Now, using these lettered coordinates, we need to prove that OPQR is a parallelogram. Well, remember, the key to a parallelogram is the OCD qualities. So just to refresh your memory, the OCD qualities are right there. Opposite sides are parallel. Opposite sides are, let's write that down. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. If any one of these five can be demonstrated to be true in this situation, then it is a parallelogram. So let's see what it would take to get any one of these five. I'm going to write it out here. The first one, opposite sides parallel. Second, opposite sides congruent. Third, opposite angles congruent. Fourth, consecutive angles supplementary. And the fifth would be that the diagonals bisect. Now, we only have these equations to work with, midpoint, slope, and distance. So we have to ask ourselves, what's going to work here? If we want to show opposite sides are parallel, parallel is a slope issue. And we have two pairs of sides. So we would have to use, if we use slope, we'd have to use the slope equation 4 times because we have two pairs of sides. Opposite sides congruent, that's a length issue. So to do opposite sides congruent, we'd have to use the distance equation. And we would have to use it 4 times. We'd have to find the distance of all 4 sides and show that opposite sides are congruent. There's really no way for us to talk about angles except right angles with slope. So we can't use this one, nor can we use this one. Now, the diagonals being bisecting, I'm going to draw on the diagonals. Bisect is an issue of midpoint. And since you only have 2 diagonals, we could use the midpoint equation, and if we use the midpoint equation with diagonals, we only need to use it 2 times. So I could either do slope equation, all 4 sides, distance equation, all 4 sides, or if I show the diagonals bisect, which means they go through each other's midpoint, then I only have to do it twice. So that's the method I'm going to go with. It's the shortest. So the diagonals are, there's one diagonal, which is O to Q, and we're going to find the midpoint that way. And then here's the other diagonal, P to R. And for both of these, we're going to find the midpoint. Midpoint equation is, let's do our templates, add the x's, divide by 2, comma, add the y's, divide by 2. The midpoint equation is, add the x's, divide by 2, comma, add the y's, divide by 2. Now let's circle, plug, chug. For O, we're going to add our x's. So I'm going to circle these in green. We have 0, and we're going to add that to A plus B. So I'm going to put that right here. 0 plus A plus B is going to just be A plus B. That's our x coordinates. A plus B plus 0 over 2. And our y coordinates is 0 plus C. So 0 plus C. Now we're going to go to PR. We're going to go the other direction. And our x coordinates are B and A, so it's going to be B plus A. And our y coordinates is C plus 0. Now let's clean it up a little bit and see what we get here. A plus B plus 0 is simply A plus B over 2. 0 plus C is just C over 2. Here, A plus B or B plus A is the same thing. I'm just going to switch it around so you see that these are the same thing. And of course, C plus 0 is just C over 2. So what we have here is the midpoint of both the diagonals is exactly the same. The midpoint of the diagonal, O to Q, is A plus B over 2, comma, and C over 2. The midpoint of PR is going to be A plus B over 2, comma, C over 2. They are the same thing. If they are the same thing, that means the diagonals bisect each other, which means that it is a parallelogram. So let's summarize this down below. First thing, we have given a quad OPQR with O is at 0, 0. P was at B, C. Q is at A plus B, lowercase, C. And R was at whatever that A coordinate is and 0. Okay, then we did this. We found the midpoint of OQ is A plus B over 2, comma, and C over 2. The midpoint of PR is also A plus B over 2, comma, and C over 2. Wait for you to catch up. Therefore, since the midpoint of the diagonals are the same, they bisect each other. And if they bisect, then OPQR must be a parallelogram.